Hello dear students. Today we'll be talking about solving simultaneous equations algebraically. In the previous lesson, we covered how to solve simultaneous equations by graphing. Today, we're going to learn another method to solve the simultaneous equations, which is the algebraic method. Let's see in this example. In this example, we have two equations. The first equation, 2x minus y equal 3. And the second equation, x plus 2y equal 4. Let's name the first equation, equation 1, and the second equation, equation 2. You're going to decide here which way to use, either the substitution way or the omitting way. You can use any of them. Let's solve this one here by the substitution way. So we're going to work in equation 2 to make it as x equals negative 2y plus 4. So we're going to substitute this equation into equation 1. So it will be 2, open bracket, negative 2y plus 4 minus y equal 3. Then, what are we going to do? Yes, exactly. We're going to distribute the 2 inside the bracket. So it will be negative 4y plus 8 minus y equals 3. Then we're going to solve for y by combining the like terms together. So it's negative 5y equals, and move the 8 to this side, 3 minus 8. So negative 5y equals negative 5. Then y equal 1. Now I succeeded to get the value of y. What do I need to get now? Good job. We need to find the value of x. So we're going to substitute this y value that we just got here into equation 3. So we'll say that x equals negative 2, open bracket, y plus 4. You can easily calculate the value of x, which will be 2. Then in this case, our solution set will be x, which is 2, and y is 1. Now let's move on to example 2. Here in example 2, we have two equations. The question is asking me to solve them simultaneously. The first equation, 3x plus 2y is equal to 21. And the second equation is x minus 2y plus 1 is equal to 0. As you all know, we must have the variables in one side and the constants or the numbers in the other side. So they have to be in the form of ax plus by equals c. The first one, we already have it in this form. And the second one, I need to move the one from this side to the other side. So it's x minus 2y is equal to negative 1. Now, you have the option to choose between the substitution method or the omitting method. As you can see here, the coefficients of y are almost the same. The first one is 2 and the other one is negative 2. So, yes, exactly, we're going to use the omitting method. Here we're going to add these two equations together. As you can see, when we add, the 2y and the negative 2y will be crossed out together. So, it's 4x equals 21 plus negative 1, this is 20. We divide both sides by 4, so x equals 5. So this is the value of x. Now we need to get the value of y. You have the option to substitute this x value in any of these two equations. Let's, for example, substitute it in the first equation. So it will be 3, and then we substitute x by 5. plus 2y equals 21. So 15 plus 2y equals 21. Then 2y equals 6. Then y equals 3. Here, I succeeded to find the value of x and to find the value of y. So in this case, the solution set will be 5 and 3. In example 3, it has two equations, and the question wants me to find the solution of these two equations algebraically. The first equation is 3x plus 2y equal 4, where the second equation is x minus 3y equal 5. Again, we can do it by the substitution method by moving here in the second equation the 3y to the other side, or we can use the omitting method. But here in the omitting method, we don't have any of the coefficients that are the same, neither of x nor of y. So you're going to decide to use either x or y to have them having the same coefficient. So for example, let's choose x. So I'm going to multiply the second equation by -3. Why did I choose -3? Because the coefficient of x in the first equation is 3. So you will see that the first equation is 3x plus 2y equals 4, where the other equation will be now -3x plus 9y equals -15. Then, how to use the omitting method? Yes, exactly. We add. When we add, you will see that the 3x and the -3x will give me 0, so they will be cancelled together. So now this is 11y equals 4 plus -15, this is -11. When you solve for y, y equals -1. Then you can go to any of the equations, substitute y by -1 to find the value of x. For example, let's go to the first one. 3x plus 2, and we put -1 instead of y, equals 4. So 3x minus 2 equals 4. So 3x is equal to 6. Now x equals, good job, 2. So here, in this question, the solution set is 2 and -1. Now let's go and see example 4. In example 4, it's a different example, that it says, find the value of a and b if the ordered pair 3 and -1 is given as a solution to the two given equations. So we have two equations, and we have the answer, which is the solution, and we need to find two variables in these equations. Let's now go and see how can we solve this. The first equation is ax plus by minus 5 equals 0, where the second equation is 3ax plus by equals 17. As I just said, that we have the solution given as 3 and -1. So we're going to go to both equations and substitute the x value by 3 and the y value by -1. So in the first one, it will be 3a plus -1b minus 5 equals 0. Yes, exactly. It will be 3a minus b equal 5. And I will use this now as equation 1. In the second equation, it will be 3, and here is the 3 instead of xa, plus -1b equals 17. So, yes, exactly. 9a minus b equals 17, and then we're going to call this equation 2. Let's, for example, multiply the first one by -3. So it will become minus 9a plus 3b equals -15, or the second equation as it is, 9a minus b equals 17. Now to solve these two equations by omitting, we're going to add. These two will be cancelled together, and then 3b plus -b is 2b equals -15 plus 17 is 2. So b equals 1. Now, I got the value of b. I can go to any of these equations, either the two original equations or my equation 1 and equation 2. So I prefer that we go to one of my equations, equation 1 or equation 2. So let's go to the first equation and substitute b by 1 and find the value of a. So 3a minus 1 equals 5. 3a equals 6. Then the value of a is 2. Now we succeeded to find the values of a and b as required in the question. Here in example 5, the question is telling me that the sum of the two digits in this number, the tens plus the units, is 11. Okay, let's write in a side like this. Any two-digit number, it comes from the tens digit multiplied by 10 plus the units digit. So if you're going to reverse it, this unit digit comes in the place of the tens, where the tens digit comes in the place of the units. So when reversed, it will become 10u plus t. So here in this question, as you see that it says, when the number is reversed, so this is the 10u plus t, it is 27 more than, so more than means plus, the original number. The original number is what? Yes, exactly. It's 10t plus u. So now we have two different equations. The first equation which says t plus u equal 11, and the second equation that is written here in the red color. So each of these two equations have two different variables. So what we're going to do, yes, exactly, we're going to change the first equation, which is the shorter equation, to make it as u equals or t equals. It's up to you to make it as u equals or t equals. So we're going to move the t to this side. So u will be equal to 11 minus t. Then you will go to the other equation, replace each u by 11 minus t. So we'll go down here. It's 10. Change the u by 11 minus t plus t equals 27 plus 10t plus change u again by 11 minus t. Remove the brackets by expanding. So this is 110 minus 10t plus t equals 27 plus 10t plus 11 minus t. Now, let's put the variables together in the left-hand side and the numbers with no variables in the right-hand side. So, we'll be moving this 10t to this side, this t to this side, and here we'll move this 110 to the other side. So, we have it here, negative 10t plus t minus 10t plus t, then negative 18t equals negative 72. So t is equal to 4. Now I know that the tens digit is 4. How can I find the units digit? Yes, exactly. I go and substitute in my equation up here that says u equals. So u equals 11 minus 4, which is equal to 7. So what is the original number? The tens digit is 4. How can I get the ones digit? Yes, exactly, as you guys said, that I'm going to substitute this value of 4 in my equation that says u equals 11 minus t. So u equals 11 minus 4. So u is equal to 7. So my original number is the tens and the units. So my original number is 47. If you want to check, yes, the sum of the two digits, the 4 and the 7, is 11. Let's now go to example 6. Example 6 is a word problem. The question says, a rectangle in which its length is 4 more than its width, and its perimeter is equal to 28 centimeters. Find the area of this rectangle. First, we need to know the givens and how to change the given into an equation, and how to use this equation to solve the problem. Let's now go and see how can we solve this question. First of all, we're going to let the length of this rectangle be L and the width of the rectangle be W. So the question says L is 4 centimeters more than its width. So L equals W plus 4. And it says as well that the perimeter equals 28. What is the rule of the perimeter? Yes, perfect. It's 2 open bracket L plus W equals 28. If I divide both sides by 2, I will see that L plus W is equal to 13. And in the first equation, it says L equals W plus 4. Then we can use the substitution method by substituting here L by W plus 4. So it will be W plus 4 plus W equals 14. So 2W plus 4 equals 14. Then W equals 10 divided by 2. So W equals 5. The question is not asking me to find W. And also the question is not asking me to find the length. The question wants me to find the area of this rectangle. So first, I need to go and find the length. So the length of this rectangle is equal to 5 plus 4. So the length of this rectangle equals 9. To find the area of this rectangle, we know that the area equals length by width. So what's the length of the rectangle? It's 9 times the width, which is 5. Then the area of this rectangle is 45 centimeters squared. So you need to think, what are the givens that we have and how can we use them? and how can we change them into an equation. Dear students, by finishing this example, we're now able to solve the simultaneous equations by the algebraic method.